Okay, look into this coding problem. What it is saying is, you are choreographing a circus show with various animals. For one act, you are given two kangaroos on a number line, ready to jump in the positive direction. So let's suppose that this is the number line. Let me take this as the number line. This is the center. Okay. And you are given two kangaroos on a number line ready to jump in the positive direction. So wherever they are, like it's saying, the first kangaroo starts at location x1. Let's say this is x1. And it moves at the rate of v1 meters per jump. So after one jump, the kangaroo 1 is here. The first kangaroo is here, which is x1 plus v. Let's say it is in meters. Okay. Then after one jump, this is where the kangaroo 1 will be. And the second kangaroo starts at location x2. Okay, let's say this is x2 and moves at a rate of v2 meters per second. It means after one jump, the kangaroo 2, let's say, lands here. Then what is the location? It is x2 plus v2. x2 plus v2. This is x1 plus v1 and this is x2 plus v1. Now what you have to do in this problem is actually to figure out a way to get both kangaroos at the same location at the same time as part of the show, and if it is possible then return yes, otherwise no. If it is possible then return yes, otherwise no. What it means to say is that when you have one kangaroo at one location, another kangaroo at another location, and they are jumping, okay, and they are jumping. So what you want is that at any moment, will they end up at the same spot? So let me make a picture clean again. So what it's saying is, you have a number line. This is your number line, and this is your beginning point, which is I'm looking as origin as O. Now you have one kangaroo here. That's the starting point of one kangaroo. Okay, I'm going to take kangaroo 1 as K1 and kangaroo 2 as K2. Okay, now this is the initial point of K1, which is x1, and this is the initial point of K2, which is x2. Now what it is saying is that x2 will jump and it will continue jump moving forward in the positive x direction. In a similar manner, x1 will jump. Let's say x1 is jumping in. X1 is taking v1 meters, covering v1 meters in one jump. Now the question is, will it happen that any time they get into the same spot? If yes, then return yes, and if no, then return no. That's what you have to do in this problem. Okay. So that's what it is. Like for example, example is given. Look at this example. Let's say this is the start point, and this is covered in one jump. Okay. So starting point of kangaroo 2 is 1, and distance covered in one jump is 2 meters. At any point, let's say it is x. Let's say any kangaroo is at this position. I am taking it as AI. Then, at what position? What will be the next position or next location of kangaroo AI? It will be x plus this distance that it covers in 1 meter. Oh, okay. So in this problem, if you look at kangaroo 1, when you add 2 and 1, what you will get? You will get 3. And similarly, when you add, the starting point is 1, and in one jump it covers 2 meters, So it ends up at 3. So Kangaroo 1 and Kangaroo 2 ends up at the same spot. Okay, they both take one jump and they end up in the same spot. Okay, so in this scenario, in this example, you will return yes. So after one jump, they are both at x is equal to 3. Okay, x1 plus v1 is 2 plus 1 which is 3 and x2 plus v2 is 1 plus 2 which is 3. So the answer is yes. Now what look at the function f1 description. So you have a function Kangaroo in the editor below, and in this function what you have to do is they are going to be for 2 parameters. Okay, they are going to be 4 parameters. One is x1 which is the starting position of Kangaroo 1, and v1 is the distance that will cover in one jump. Okay, or jump distance for Kangaroo 1. Similarly, x2 is the starting position. Okay, and v2 is jump distance for Kangaroo 2. And what you will return is either yes or no. What you will return is either yes or no. Depending on what, you will return yes if they happen to stop in their journey towards the infinity. In their journey towards small stability, if that happens at any moment, if it is possible for them to meet at any point, then you return yes, otherwise you return no. What are the constants? So x1 and x2 they cannot exceed 10,000 and v1 cannot exceed 10,000. It's between 1 and 10,000, and v2 is between 1 and 10,000. So now is the time to actually do and solve this. Okay. So just because look at the return type in this example. Return type is a string, because you have to return yes or no. And all the parameters is x1, v1, x2 and v2. All the parameters are integers. Now let's get into the logic part. Okay. What would be our approach? So number one for it is you have to look at x1 and x2. If x1 is equal to x2, just in case x1 is equal to x2, then you just send it as yes, because they are already at the beginning, they were in the same spot. But if x1 is not equal to x2, in that case, you have to look at if x1 is greater than x2, or if x1 is less than x2. Means, if this is the number line, okay, then maybe Kangaroo 1 is here, and maybe Kangaroo 2. So Kangaroo 2 can be here, or Kangaroo 2 can be here. So when x1 is not equal to x2, this is what the case may be. If, or like Kangaroo 2 will be ahead of Kangaroo 1, or Kangaroo 2 will be lagging behind, or at the back of Kangaroo 1, means at the back side. In case x2 is, in case x1 is ahead, means Kangaroo 1 is ahead of Kangaroo 2 at the beginning, then the speed of Kangaroo 2 has to be greater. Otherwise, they will never meet. So, if this is the case, that there are two situations. One is when x1 is greater than x2, and when x1 is less than x2. Now, the case when Kangaroo 1 is ahead of Kangaroo 2, and Kangaroo 1 is also faster than Kangaroo 2, then they will never meet. Then you will return no. Similarly, in the case when Kangaroo 1 in the case when Kangaroo 1 is lagging behind or Kangaroo 2 is ahead of Kangaroo 1, means this scenario. In that case, if that is the case, and Kangaroo 2 is faster, then also they will never be able to land at the same spot ever in their journey in the positive direction. Okay? So the situation comes that if x1 is greater than x2, if Kangaroo 1 is at the beginning is ahead of Kangaroo 2, then but Kangaroo 2 is faster, then there is chance that they may meet. And similarly, when Kangaroo 1 is behind Kangaroo 2 at the beginning, but Kangaroo 1 is faster than Kangaroo 2, then there is a chance that they will meet. Okay? So we will look at these two situations. We have to actually write the logics for these two situations, or we have to consider these two situations in some detail. And for other situations like this, you already know what is, if it is yes or if it is no. Okay? So what is happening is, the kangaroo at the start, whichever kangaroo is at the back, it should have more speed than the one which is ahead at the beginning. Okay? Right? First point. Now because this kangaroo has more speed, then over the period of time, and they are both are moving in one dimensional, in the same direction. So over the period of time, because this one has more speed, it will overtake this. Okay, it will overtake this kangaroo, right? So we can look at the position of this kangaroo after each jump, and we will continue update it in x1 and x2. Okay, and we will continue doing it till the time x2 or the one which is behind. Let's say x1 was behind, so we will continue doing it till we get x1 to be greater than x2, because once Kangaroo 1 surpasses or overtakes the Kangaroo 2, okay, once Kangaroo 1 overtakes Kangaroo 2, now they are never going to meet again because it has more speed. So we will keep on updating this value of x1 and x2 till the time x1 is greater than, till the time x1 is less than x2. When x1 is no more less than x2, it means, and x1 gets greater than x2, it means that you have to return no, they will never meet. But if, and also it might happen during this that you may get x1 equals to x2. In that case, you just return yes and break. Okay, so this is one of the way. Okay, if I think I've explained it good. Let me write the logic for it also, so as to, if any explanation is more required, it will be covered in the logic itself. x1 equal to x2. Then yes, we have to return yes. Return yes. Okay. If x1 is greater than x2 and v1 is also greater than v2, then they will never meet. So you return no. Now when x1 is greater than x2, if this is the case, then it might also happen that x1 is greater than x2, but v1 is less than v2. Okay, I will write the logic for it here. Else if x1 is less than x2 and v1 is less than v2, then just return no. Right? Means if x1 at the beginning is behind it, also it is slower. They will never meet. x1 is less than x2 and v1 is greater than v2. x1 is less than x2 and v1 is greater than v2. Then I will write the code for it. Okay. Now what will be the code for this? I am writing it here. Every time Kangaroo 1 takes a step, I am updating the x position that it lands in. Similarly, every time Kangaroo 2 takes a step, I will note it out as I will update x2 with that position. Okay. And how long I am supposed to do this? I am supposed to do this till the time, so x1 is greater than x2. Okay, so I am supposed to do this till the time x2 is less than x1. Till the time x2 is less than x1. And after every updation of x1 and x2, I will check if they are equal. In case they are equal, I will return yes. Similarly, what logic should be here? It is very similar to this one, only slight changes, which is while. So here x1 is initially, x2 is ahead of x1. So I will check till the time x1 is less than x2. I will keep updating my x1 and x2. Okay, so x1 plus equal to v1 and x2 plus equal to v2. And if x1 equals to x2, then return yes. it will come out of the while loop, okay, either to this break statement or it will run completely and x1 will never be equal to x2. Okay, whatever it is, I can always put I can always return no based on that. So if out of the while loop I will check x1, x1 is not equal to x2. Okay, so the thing is, if x1 was equal to x2, okay, then return would have already returned. Okay, but if the while loop is exhausted without this break statement, if the control has come out of while loop uh, because x2 becomes greater than x1, it means that x1 is not equal to x2. Or you can directly check in this scenario if x2 is greater than x1. Okay, but I will use the same if condition down under this else if also. So I am writing more general, x1 not equal to x2. Okay. So if x1 not equal to x2, then just see out no. In a similar manner, out of this while loop, if x1 not equal to x2, or what you could have written here, or I would have written that x1 becomes greater than x2, or simply I could have written x1 greater than x2. Both would work. Let me just copy the code and have the right and submit it, and we can very well check for all these conditions, like giving the specific values to x1, x2, v1, and v2, and check if the code is running or not. But I think it is well-made code, so it will work. So let me just directly run it on the Kangaroo. Now, in place of cout, I will change it to return. Okay. Control reaches end of long white function. Okay. So the problem actually is, the code is correct itself. Let me tell you what it is. See, the return type is string, and that is why in return I'm sending sometimes as yes and sometimes as no. Okay. But the problem is, you have if statement and else if statement. Okay. And it is ending like that only. The compiler has to be sure that this function returns a string, no matter what. But the problem with in that case, the problem with if and else it will be that what if all the times none of the conditions get met, then this function will return nothing. If none of the conditions inside this if block, condition of if or condition of else if none of the conditions, if all those conditions get to be false, then this function won't be returning anything. So what we should do is, so what I can do is, I have to return according to these conditions. If this is the condition, I can very well return no directly outside of if portion. Okay, return no. Let's remove this one. Okay, and this will work fine.